Hi, I'm Aaron Stash with the Electric Home Show. We're here today in Champaign, Illinois to look at this 105-year-old all-electric house. Let's go take a look. I'm Aaron Stash. Welcome to the Electric Home Show. Hi, I'm Aaron Stash with the Electric Home Show. We're here today with Alex Long in Champaign, Illinois to talk about his 105-year-old all-electric house. Alex, good morning. How are you today?
I'm good. How are you?
Good. Thanks for inviting us over.
Sure.
So tell us a little bit about your house and the journey that brought you to electrification.
Yeah. So, I've owned this house for about 12 years now. Bought it for pretty cheap. It was a house that needed a lot to be done to it, a lot of love. It had a nice layout, but there were a lot of other things wrong with it. I could look in the walls a little bit, see there was a bit of insulation, a bit in the attic, but kind of a mess in a lot of other places. And so then, it was actually around when COVID hit, everyone was kind of locked down and stuck in their own homes. I've always had this background in kind of HVAC and energy efficiency. At Build Equinox, one of our first projects was the Equinox house in Urbana. Right. And that was where we got to try out a lot of these new technologies and learned a lot about how to properly seal a home, how to properly insulate a home, and then what things are cost effective for doing that.
So while other folks were making sourdough bread, you were electrifying your home and adding insulation and air sealing and all these cool things. What we didn't mention is that Alex is a co-founder of Build Equinox, who manufactures the CERV2. I have a CERV1 in my house. It's model number 6.
Yes.
In the journey to electrify, did you put solar panels up first, or what was your process there?
Solar panels were the last thing that I had put up.
All right.
Before I was on natural gas for heating, for water heating, and it didn't really make a whole lot of sense to start doing that yet. Once I got things down to where I was at a reasonable, comfortable level for conditioning the house with heat pumps and everything, then I had a good baseline to determine, okay, this is how much solar I actually need for it.
That's great. I think what we see a lot is folks think, oh, I need to be energy efficient and I'm going to put solar panels up immediately. Mm-hmm. And solar's great, but if you don't necessarily know how much energy you're using or will be using, then how much solar should you put up? Take us through the process of the home. We were talking about you insulated the walls in the basement. Mm-hmm. Did you do air sealing? Did you do other things kind of before getting to the mini splits or the heat pumps? So the mini splits and heat pumps were kind of the first real big thing that we did for the house. Sorry to cut you off,
Sure.
Did your furnace, did it die? It was just end of life? Or you're like, hey, I'm done with gas, let's do this?
Yeah, it was, this is our workout space. So we've got our gym down here, and pets are down here. I've got my workbench over there. And you'd always walk around the basement and you'd kind of get a whiff of gas every once in a while, and you could never pinpoint where it was. But then it was an old, 80% efficient furnace. It's drawing in basement air, combusting that, exhausting it out the flue.
Yep.
Same with the water heater, exhausting that out the flue. And I just knew, I could tell our air quality wasn't very good, especially bedrooms. Even with an old leaky house with old windows, things just weren't great there.
Yeah.
And so getting off gas was kind of the first thing that I wanted to do. I just wanted it out of my house. I didn't want to be paying the $20 monthly fee for gas. And I knew that, I could insulate stuff. I could get to things when I got to it. But it was kind of the right time with being at home so much that I could, it was my dad and mostly me that were replacing all of the HVAC in the house. Yeah. So we tore out the furnace, the AC, the water heater all ourselves. And put all this in ourselves.
And talking about getting to things when you can. So it wasn't necessarily that you did everything all at once. Mm-hmm. You had built out a plan of here's what we need to do. Obviously, working at Build Equinox, you understand how all this stuff works. Mm-hmm. So you know where to source the equipment. And you really, this was a DIY project for you said.
Yeah.
Well, for your dad and yourself.
Yeah. Yeah, it was fully DIY. And, it was very much I tend to take somewhat of an experimental approach with a lot of things where I'll do something and then see the repercussions of that or how things need to be adjusted, and then I'll do more. So first we had put in the heat pumps, we put in the CERV here, and then that first winter, I didn't have the furnace here. That furnace was radiating heat, so the basement was fine. The first year with just heat pumps, the basement was really cold. Like, it was dropping down into the high 30s. And so then that was like, okay, I need to look at where I'm losing heat. I need to look at, the basement walls for one. Like, I could measure that with a little infrared thermometer, and I'd see 40, 30.
Right.
It was cold.
Because again, we're in a 105-year-old house.
Yeah.
Insulation probably wasn't the number one thing on their mind 105 years ago.
Right.
And like you said, the gas furnace was just radiating heat for the basement. So you're like, yeah, it's comfortable down here.
Yeah.
Until I take that radiating box away.
Yeah. So then the second year after kind of getting the feeling for this, then that was when I insulated the basement walls. Yeah. And I used about 3 inches of polyiso just all around the perimeter of it. And then I also spray foamed all of the rim joists just with one of those kind of DIY kits, which worked out great. As long as you do your research, you wear proper protection and
that's right.
ventilators.
This is where we cue
everything.
the disclaimer that says make sure to do the research and read the instructions on how this works.
That's right. Yeah.
But ultimately, you're adding insulation, you're adding air sealing, you're making sure that the energy isn't escaping your house in the winter, or maybe even coming in your house from the cold outside or the warmed in the summertime.
Right. Yeah. And then I did add another heat pump for the basement as well to help keep the area, the insulation helped a ton, but I do need some heat input to the area, especially with a heat pump water heater in the basement. In the summertime, I really don't need to run my heat pump in the basement to cool it because the heat pump water heater helps keep it cooler. In the wintertime, I do need that heat pump to help condition the air that's been kind of deconditioned from the heat pump water heater.
Thanks for watching the Electric Home Show. If you're a homeowner interested in a healthy, energy-efficient electric home, reach out to us at electrichomecompany.com to schedule your free virtual coffee today. Thanks for watching.
Hi, I'm Aaron Stash. We're back with the Electric Home Show here with Alex Long, co-founder of Build Equinox. We're going to talk about the CERV, the Conditioning Energy Recovery Ventilator. So Alex, I have one of these in my house. It's a little older than this one, but tell us what this does.
Yeah, so the original idea for the CERV came out around maybe 2009, 2010. We saw the passive house movement starting to get some momentum in the US, and people were really sealing up and insulating homes, but they weren't really paying quite as much attention to indoor air quality. You might have an ERV or HRV that's kind of got this constant airflow into the house, but it really doesn't know what it's doing in there.
And really quick, an ERV is just an energy recovery ventilator. What's the HRV?
Yeah, HRV is heat recovery ventilator. Okay. So a difference between an ERV and an HRV is one of them, the energy recovery ventilator, also exchanges some moisture, where the heat recovery ventilator does not exchange moisture between air streams.
And how do I know when to use which? Is it certain climates that I'm in, or locations?
Usually climates is how they determine it. Honestly, between like ERV or HRV for your climate, we recommend the CERV for your climate because it really doesn't matter. The CERV can go, from down to Florida up. We have a ton in Canada. Like any climate, not a problem for it. And so an ERV, it's basically 2 fans and a heat exchanger core. And it's just as you're exhausting one side and bringing in fresh air, it's exchanging energy between those. And it's a very simple, just kind of mechanical transfer between air streams.
And so this is helping us get rid of like that sick building syndrome, right? These are the lungs of the house, bringing in fresh air, expelling stale air.
Yeah, but with a lot of systems, you're just kind of setting a fan speed for it. It's just going at a certain CFM, cubic feet per minute of air. It's exhausting that much. It's bringing this much back in. Maybe if you have a little switch in your bathroom to trigger it, it can ramp that up a little bit. But it doesn't know if you're there. It doesn't know if there are 10 people there. And so with the CERV, we went a different route where we're looking at actual indoor air quality in the house. So we're looking at things like CO2, VOC. We're measuring the temperature in the house, the relative humidity, also temperature and relative humidity outside. And then one of our new options that we just released for it is a particulate sensor. So it can monitor both inside and outside particulate mass and particulate count. And when it sees, if you're cooking bacon on the stove, as soon as that starts frying, those particulates just go everywhere. And the CERV sees that, it automatically can kick into ventilation mode, and it'll ramp up and exhaust those until the air quality looks good again.
Yeah.
Same with CO2, same with VOCs in the house. As it sees that your air is polluted, it will increase ventilation, remove those pollutants, bring in fresh air, and then the C part of CERV, conditioning, it has a small heat pump inside of it where it's doing the energy exchange between those air streams. So in the summertime, if it's ventilating because you're taking a shower or you're cooking, it will take that outside air, that hot, humid outside air, it'll cool it, dehumidify it, bring it inside, and then distribute it through the house. And it's taking that inside air that's polluted, and it's extracting the heat from that and putting it into the other airstream. And then vice versa, in the wintertime, it actually heats up that outside air and delivers that inside.
And then this is also filtering air too, right?
Yes.
So when we're talking about particulate matter, so from the outside, that's wildfires and other smoke and things like that, but you're actually filtering that as it comes in, correct?
Yes. So within the last few years, we've had so many wildfires that we're feeling the effects from in central Illinois, like the Canadian wildfires. There's just a yellow haze around. And so this will detect those particulates from outside. And if it sees, hey, outside particulates are higher than inside, maybe we don't want to vent when CO2 is high or when VOCs are high. Maybe we want to keep that air inside because outside is actually like dangerous air. Like that's actually bad air. And so instead of ventilating, it'll go into air purification mode where it's just recirculating air, filtering it. It's got UV in there as well that it can use to kind of kill off any viruses and bacteria. But it knows to keep that outside air out if it's not good air.
And that recirculation is a little different than an ERV because there's actually another filter, I think, right? As you're recirculating your indoor air. So you're kind of scrubbing it again. And then you mentioned UV light. Talk about kind of those two things.
Yeah, so it comes with two filters in it. We used to ship it with MERV 13. Now we're moving up to MERV 14 just because we've seen more people want that extra filtration. So it has a MERV 14 filter for the indoor air and then a MERV 14 filter for the outdoor air. So no matter which way the air is coming into your house, it's getting filtered. And then it has an ultraviolet lamp inside of it that actually shines on the heat exchanger of the heat pump, so the aluminum heat exchanger there. So it can help prevent any growth of bacteria or anything on your heat exchanger, but then it also shines up onto the filter above for the return air.
Okay.
And Ty Newell, one of the other co-founders of the company, did a study on this where he cut little samples out of his filters and then put it in a little petri dish and then, kind of grew colonies on there from existing indoor air. Wow. And there's tons of bacteria on those filters. And then he put in the ultraviolet lamp and then let that shine on it and put it in the petri dish and nothing there. So it helps kind of sanitize the filters as well, which is a big, you don't want bacteria growing and then, picking up into your air and getting distributed around.
And so this is almost, correct me if I'm wrong, like hospital grade air for your house. Is that fair?
Yeah, I would say so without the legal implications of saying so.
The lawyers won't let us say that.
But yeah, no, I mean, it's watching what's going on in the house and it's making sure that it's not unhealthy air.
Okay.
Like it's doing everything it can. That's the whole purpose of it. The conditioning in CERV, that's a useful tool for it, but really the heart of it is all of the air quality sensing and that ability to respond to it.
Yeah.
And then, it has the ability to as well, it can control zone dampers in the house. So I have a zone damper that's
so
going...
yeah, tell us what's a zone damper first.
So right up here, if you can see that,
okay.
that's a little damper, little orange damper motor, and then a section of duct, and it's got a flapper in there.
Okay, so
and
it's kind of turning my duct on or off.
Yeah, and so with some remote sensors, so I have a remote relative humidity sensor in my bathroom. If I go up, I take a shower, that humidity starts to spike, and that sends that humidity reading back to the CERV, and the CERV goes, hey, humidity's gone up. This sensor has been configured as a bathroom sensor. So it can then go into ventilation mode, and it will close down the other zone dampers in the house. So it'll close down the half bath zone damper, it'll close down the kitchen zone damper, and it'll pull that air from that bathroom so that it's getting, you know, the most polluted or most humid air, and exhausting that as quickly as possible.
So it's like a targeted ventilation in that sense.
Yeah.
And is there a sweet spot for where this should be set at? Like, you know, my old house, I didn't know how much CO2 was in that house. Like, well, how much CO2 is too much CO2?
All of our recommendations come from studies that we've seen with regards to indoor air quality. So for CO2, a lot of studies show that above 900 to 1,000 parts per million is where you start to get some measurable effects on things like sleep quality and cognition. There's kind of a hangover effect from it the next day if you've got poor air quality while sleeping. So we like to recommend around 800 to 900 parts per million for CO2. And then for particulates as well, you know, there are guidelines on what those should be, and we typically recommend around 10 micrograms per cubic meter of particulate mass, PM10. That's where we recommend keeping your house below, and that's just an automatic thing the system does. You know, you're not
right. I don't have to sketch that out or get the graphing calculator out. That's all going to do that for me.
Yeah, and it can seem a little overwhelming at first, like there are all these different numbers and everything. But you're not going in and you're changing your CO2 set point. You're changing your VOC set point. You're just setting that
set it and forget it.
It should be, and then it's staying there.
If you're an industry professional interested in joining our network, reach out to us at electrichomecompany.com. Thanks for watching.
Now, you've done something unique, I think, with this CERV just above your head. Tell us what's going on here.
Yeah, so where I'm standing right now, this is where the furnace was before. Okay. So it's, you know, one of those big things, just octopus ductwork everywhere, leaky as anything. And so, you know, we took that out. That helped open up this gym space quite a bit too. But I'm using these low, medium, static indoor heads for my Mitsubishi heat pumps.
Okay. Oh, so this is a heat pump right here. Just looks like ductwork to me, but you've got a machine in here.
Yeah. So you can see over here, these are the refrigerant lines that are coming into it. So those go outside, and then it's got a wire connecting into it, and then controls for it. And so this is the air handler. This is the indoor coil as well. So this then basically draws air from this side and blows it out here while conditioning it, and then it supplies it into these ducts. And so part of this house project, something that took a lot of time, was tearing out all of the old ductwork, which was just everywhere and inefficient, and kind of laying it out a little bit neater, insulating it, making it make more sense, and then zoning it. So this is actually the heat pump for the second floor. So the ducts here go to some existing ducts that were in the walls, and that's just pushing up air into the second floor. And then I've got another heat pump right there. That's the heat pump for the first floor.
Wow.
So that then just runs to the floor registers on the first floor and distributes air there.
And so instead of doing, you know, in our house, we have wall units, they're ductless units, or some folks have kind of a central system. Why did you choose this system, you know, versus those two options?
I really liked the idea of zoning the house to have a first floor and a second floor that were independent, because coming from a house that was centrally ducted before, that was fairly leaky, that was fairly poor insulation, the second floor in the summertime just got hot as anything. And then in the wintertime, you know, it just never was even between floors. And so this then lets me keep the house even, Or at night, I can cool down just the second floor in the summertime. I don't have to cool the first floor too. So it lets me be very flexible with how I'm keeping the house conditioned down. Yeah, so this is about 2 tons of heating and cooling capacity total. So 2 1-ton units. I could have done a 2-ton or even 3-ton, central multi-position air handler. And those are very common now, and they're very popular. They can do a good job of pushing air through ducts if you've got a very big house, and it makes sense in some cases. And that's the whole thing, is just finding what makes sense.
Right.
In this case, these made a lot of sense to me because I'm short enough that I'm not bumping my head on these while I'm in the basement.
Here for me, but
yeah,
that's all right.
I've got some
that's why we got
tape
the
there.
Safety tape, right?
That's right. Yeah. But yeah, it made a lot of sense to do it this way. And then so the 2 indoor 1-ton heads, these have a central return in the dining room above us. So it's a very short, just couple feet return. But then one of the unique things is that the CERV2 feeds into that. So this is the supply outlet of the CERV. So when it's bringing in fresh air, the fresh air is conditioned, and then it comes through here, and then it goes through this duct and comes right into here. So that's
a pretty unique setup, right?
Yeah.
So a lot of folks, again, I've got duct work for my CERV, and I've got these ductless systems.
Yeah.
But this is all combining together.
Yeah, and we see this is a very popular combination where people, they may use that central multi-position air handler, and then the CERV might just draw right into it. It just pushes right into that, and that helps spread air throughout the house.
Yeah.
Some homes will have, like yours, will have dedicated ductwork on both the return side and the supply side. In the case where you've got your ductless mini splits, that makes a lot of sense because you want that air to be moving around through the house. Where you've already got some ductwork going throughout the house, and you have this system that's providing most of the heating and cooling, it makes sense to use those big fans, just feed that conditioned fresh air into that and help distribute it with these guys.
So a really good option here for a retrofit for a home, again, 105-year-old home, to put this new system. I don't know how many zoned HVAC systems there are in 105-year-old houses, but it's possible, right? Now, these 2 indoor 1-ton units, are they fed by 1 unit outside, 2 units? Or?
2 units outside.
Okay.
You could do 1 unit outside. One of the nice things about having 2 1-ton units versus 1 2-ton unit is the amount of turn down for it. You're also getting some redundancy. If one of my units just stops working, I still have one other heat pump that's doing that here.
So you were also saying the ability to zone it.
Yeah.
So theoretically, you could be running 1 in heating and 1 in cooling.
I could.
Which you couldn't do if you only had 1 unit outside.
Exactly.
It would flip back and forth.
Yeah.
And the other thing I was going to ask then, so we're in Illinois, we're in central Illinois. I think Ty once told me this is the worst weather possible in all the United States. It's really hot and humid in the summer. It's extremely cold in the winter. We get like 3 or 4 days of nice weather, and then we go back to the the problems. But the big thing I always hear with heat pumps is, well, they don't work in the wintertime. Do you have backup heat, or how much are these working when it's super cold polar vortex time period? Yeah,
I mean, now heat pumps, I'd say almost every heat pump that's cold climate rated, it'll operate down to -15 degrees. And you can see, like, on their design guides, they'll tell you how much capacity that they have at that temperature. And so usually a lot of systems now, they'll keep 100% capacity down to maybe 5 degrees. And then it'll start kind of lowering a bit.
Yeah.
But if you're doing energy calculations, if you're doing load calculations for your house, then you should be able to kind of tell, okay, I'll need this much capacity at -15 degrees. But we're even seeing some -30 degree Fahrenheit cold climate heat pumps coming out. And then we're going to be seeing more propane heat pumps, which use propane as a refrigerant instead of R410A or any of these other high global warming.
So the new
potential
refrigerants can actually run more efficiently at even lower temperatures.
Yes, yeah.
Thanks again to Alex Long for sharing his all-electric home transformation using the CERV2 Conditioning Energy Recovery Ventilator from Build Equinox for fresh air and multiple ducted air source mini-split heat pumps for heating and cooling. We'll be back in Champaign, Urbana for part 2 of Alex's journey. Stay tuned for more, and go Illini! I'm Aaron Stash. Thanks for watching the Electric Home Show. Like and subscribe for more.